Okay, in the previous video, I ran out of time, but we were addressing questions 6H3 through 6H5, and the basic idea was that we had this DAG and some data that are part of the Rethinking package, and we were trying to find the causal effect of area on weight, of average food on weight, and group size on weight. And so we did this with 3 separate models. And the thing that we recognized was that in the model that just includes area and in the model that just included average food, it seemed that there was no effect of either of these things on weight. However, when we looked for the causal effect of group size on weight, we had to condition on average food, okay? Because there's a backdoor path from group size to average food to weight. And upon doing that, what we realized was that it seems that there was a causal effect of food on weight and on group size on weight. It was just that those effects seem to be approximately equal and opposite. And so, in other words, the causal effect of food on weight and of area on weight were masked because group size had an equal and opposite effect on weight as did average food. Okay. Now, all of that interpretation I just gave you, as well as all the interpretations that we discussed in the previous video, are contingent on this DAG being accurate, being a good representation of the actual phenomenon, as well as the data. Okay. And so, even though the question does not ask us to, I started and did not get very far on what I'm calling a bonus section, because it's not asked specifically in the questions, but trying to assess how good that DAG is as a causal model. Okay, and here's the DAG recreated. Okay, and so the first thing that we did was we looked at the implied conditional independencies that are implied by this DAG, and we got 2 of them. That A should be independent of S given F, and that A should be independent of W given F. Okay, and to this point, no model had actually tested either of those implied conditional independencies. Okay, and so we're going to test those. Another way we can test the model is we can look for, we can try to estimate the size of the effect of A on F and on F on S, and to see if it looks like A actually mediates the effect of, if F mediates the effect of A on S through this path here, right? And so we can try to assign and look for those types of things. Okay, so I have a series of models here. Okay, one looking at the effect of A on F. Okay, the effect of A on S, the effect of F on S. Okay. And the effect of A on S when I account for F. And incidentally, this is testing one of our implied conditional independencies. Okay, so I've ran those models, and I have the summary outputs here. All right. So for the first model, again, which is testing the effect of A on F, okay, we see that there is a positive association. So it looks like area does somehow affect food availability. Okay? Now the second model was testing the effect of A on S, so area on group size, and again it seems that there is a positive association, suggesting again that this is a real path and this is a real path. Okay, from A to F and from A to F to S, that those are legitimate paths. Okay, and also with the third model, F on S, again, there's a positive association between food and group size. Okay, so again, these paths seem to be legitimate. But now we get to this fourth model, where I'm looking at the effect of A on S after controlling for F, okay? So in other words, I'm trying to test if F really is acting as a mediator for A to S, all right? And so if that is the case, then I should expect to see that the effect of A on S, represented by the BA coefficient, drops to 0 because I've accounted for F. I've accounted for the mediator. And when I go to the output for that, it does not look like that's the case. It looks like there is a reliably positive association that remains between A and S after accounting for F. All right. So it seems then that the implied conditional independency, A being independent of S, given F, probably is not accurate, at least not in our data sample. Okay, we may need more data. We may have a biased sample, but given the data that we have, it does not look like that is actually the case. So we have failed one of the implied conditional independencies, right? It seems that there is some additional paths between A and S, right? So it looks like not only does A connect to S via F, okay, it looks like there might be additional paths. I recognize I should clarify something. I just said it looks like A does connect to F the A connects to S through F, but that there's additional paths. But how do I know that it looks like A connects to F through S? Well, it's because whereas in the first model, or in the first model where we're testing the association between A and S, we get this size of a coefficient. That coefficient has dropped here, right? So this is some evidence that that A is affecting S via F, right? Because we've controlled for F, and now the coefficient for A to S has gone down. All right. But nonetheless, I still think that we've probably failed that implied conditional independency. Right? It does not look like A and S are independent after conditioning on F. So now let's check the other implied conditional independency, which is A independent of W given F? All right. So I'm going to run that and look at the summary output. Okay. So here we have. Okay. Now this is a little bit interesting, and this is ambiguous to me, because on one hand, it does not seem that the best estimate is that there's zero association between A and W, between area and weight. Okay. But the credibility interval does spread across 0. It is, however, quite skewed to be positive. Okay, and so this is it would be hard for me to really be convinced that A, when I account for F, is independent of W. Okay, it'd be hard for me to say that we've passed this test given this. The other interesting thing here is that the association between A and W is about equal and opposite. Between F and W, and we've already seen that equal and opposite motif. I think it must have been in the last video where we discovered that masking phenomenon. But we've already seen that motif here in Model 3, right, where food and weight have a positive, about a 0.5 association, and then group size and weight have a negative association of about the same size, roughly the same size, not exactly. Okay, and so the fact that both of these show this equal and opposite relationship suggests to me further that there are more paths connecting A to S, right? That there must be other ancillary pathways that connect A to S. Okay, so what happens? So what happens if we additionally condition on S? If we're regressing W on all of these guys, what do we expect to happen with the coefficient for A? Well, I suspect, if the DAG is correct, then, or if the DAG is correct all but just like a path that goes from A to S, by additionally conditioning on S, excuse me, the coefficient for A should drop to 0 in that case, okay? And so let's also do that. So here I have that model. I have all the variables in there. I've conditioned on everything. And again, if the DAG is correct except for an ancillary pathway between A and S, then we should see that the coefficient for A drops to 0. Okay, and what happens? It's a mess. So we could spend some time trying to start to decipher what's going on here, but I think that what's important is to recognize how difficult it is to assess causality, right? Like, so we've gone through several models, and had we stopped at any point in the previous video before model 3, we probably would have come up with a false conclusion. Here, even after we've taken that, we've gone to even more extents trying to demonstrate or to test the validity of our model. When it comes right down to it, we're still flummoxed. Okay, we're still flummoxed, and so that suggests that there are things about this phenomenon that are outside of our data set. Okay, that's it. Thank you.